along my PhD project, which is an amazing project, and that's why I want to introduce it to you, but I need your help. I will be talking about waves a lot, and to give you an idea what a wave looks like, I would like you to do a wave. So can you all do a la ola from me, from the beginning to the end? You can stay seated, just use your arms. So if we start a la ola, excellent, brilliant. So every time I say the word wave, guess what's going to happen? So retry, wave. Thank you very much. The other word I'm going to use a lot is seagrass. A bit like this. Yeah? Seagrass, you might guess seagrass is usually not red. It is green, but real seagrass would be very unhappy in this room, so I didn't bring it along. But this is equally floppy. It will stay upright underwater, and it does move under waves. Excellent. So, can I ask you to do seagrass for me? So, seagrass, I think you get the gist of it. And we get another seagrass over here, please. Thank you very much. So, as I said, seagrass moves under waves. Yes, you got the message, brilliant. So, we can start. Waves come to the shore and meet seagrass on the way. And I wanted to know what happens in the process when the two interact with each other. There's a lot going on. Wind plays a role, the tides play a role. When the seabed goes up, something is changing, but there's also something happening within the meadow. The vegetation moves back and forth, there's turbulence happening, and that's what I wanted to have a look at. How do you learn things best? You ask people who know a lot about it. So you go and ask an expert. That's what I did. I asked Wash and Wendy. Wash is a boat wave, there we go, generated at the end of a boat traveling to the shore. He is characterized by about 10-second period and is very steep in his characteristics. Wendy, on the other hand, is a nice gentle wind wave. Here we go. About 3 to 4 period seconds, and the height is very low compared to the water depth. So I asked those two waves, brilliant, what they feel when they meet seagrass. There we go. And they said, oh, I don't know, when I see a beach, I want to go there, I want to play with the kids, I want to splash them wet, I don't pay attention to all this green stuff on the ground. I can't write that in my thesis, can I? So I thought, okay, can you please help me? Can we do a test? And I said, oh, okay, go on, let's do a race. So I set up a course, set up a nice line of instruments, the deep water here at the top, that's where Wendy comes in. Wash is generated at the ferry terminal at the very top, and they both come to the shore to splash about with the kids. You can see these green patches everywhere, that's the seagrass. Excellent. So hopefully I can see what happens when those two travel along. We did this in February. We had 600 plants per square meter. Sounds a lot, is very little. You can see there wasn't much to see of the vegetation. And equally, both said, well, there's nothing happening. They both looked the same at position 1 and position 7. There was no difference whatsoever. Again, nothing I can write into my thesis, can I? So I talked to them again, said, please, can we do this again? I really need good data. So they said, oh, go on, okay, come on. It took me a while to convince them. So in July, we met again, same place. The ground looked different. We had more than 4,000 plants per square meter. The whole lot looked nice and green. So you can say, okay, there's a difference. Thank God. And what happened? Wendy, our nice wind wave, still working, brilliant, reached the shore without any problems. It just traveled along, splashed around with the kids. Wash, the grumpy boat wave, on the other hand, lost energy on the way, looked a lot smaller when he reached the shore than in the deeper water. So there was a reduction in height and a loss of energy. And I thought, oh great, I can use that. That's brilliant information. But what actually happens when you meet the vegetation? I don't know, I just travel along, God knows what's happened, I don't care. Again, not very helpful. So I went and found another expert. who's called clone. He's a wave, and a wave, and a wave. Yes, he is identical to all the waves around him. He works in a Dutch lab, and there he just does experiments and was able to tell me something about it, and he gave me this graph. And he said, yes, you're absolutely right, the more biomass, so the more plants you have there, the more energy will get lost off that wave. You get more attenuation. So basically, this is biomass, this is attenuation, and you can see the relationship, and the black line is our seagrass. Exactly that. And I thought, okay, what's the other line then? And he said, oh, you know, sometimes plants aren't that flexible, and if you use something stiff like this, you'll get a different line. So the material also plays a role in how much attenuation you get from the wave at the same biomass. The other thing he told me, which is represented by the triangles here, which I found really fascinating and where I will continue my work in the future, is that a meadow that has long leaves but is sparsely distributed can give you the same attenuation than short leaves that are very densely distributed. So it only depends on the amount of biomass that you have in the water rather than on its height or on its distribution alone. So, to remind you, what did we talk about? We had the influencing factors on the waves. Excellent. So there are some parameters that play a role, which the comparison between Wash and Wendy showed us, which is basically the parameters, the length, the period, and the steepness of those two made a difference when they reached the seagrass. Seagrass, thank you. But there are also the vegetation parameters, which is the length and the density, which combined are the biomass. And there is the stiffness, because it simply moves very differently under the energy. But I told you at the beginning I want to look at the interaction, and this was only one way so far. So what's the other side of the story? I asked Strip, a nice friendly seagrass, thank you. He chats a lot and I had to cut him short at some point, but he gave me very useful information because he said that all this splashing under those waves is terribly exhausting. Yeah? And he just flopped over. But the other thing he revealed was they seek safety in numbers. They're not that stupid, those little seagrasses. And the denser they grow, the easier it gets for them. But he also had to admit that when the waves go bigger and bigger, it gets more and more exhausting, and eventually they will break off. And this is what you can see, especially in autumn when the first storms come. You get lots of loose seagrass floating around and disappearing into the ocean, and you end up with a picture from February where there's hardly any seagrass around. In return, they will grow back another day, namely in July, and then we can do the experiments all over again. And I hope that next summer I will meet all of them again to do some more tests. Thank you very much.